Okay, so next is yeah, difference between array and pointer. Okay, so let's go to the basics first. What happens when you initialize a variable? So compiler will allocate a memory depending on the size of the variable. So if it is an int type variable, then it will take 4 cells out of your free memory and it will assign this to the name. Let's say a we have made. So these two will be linked with each other and a will point to the address of the first element, right? This here it will point. Similarly, when you make an int ARR, let's say 5, and you give some data to it or whatever, if you don't give, then it will be initialized with garbage value. But what compiler will do, compiler will again take the memory whatever it wants. So in this case it will want 4 times 5, right? 20 bytes. So it will take 20 cells from the free space available basically in a stack, and it will make this ARR point to okay. So yeah, and this will point to this. So ARR, basically what people confuses is ARR is a pointer because it supports similar features of a pointer, that it can support pointer arithmetics and whatever, but it is not the case. ARR is actually representing this whole chunk of memory. Okay, whereas if I make a pointer int star p and I put ARR in this one, then it will, this p will represent individual 4 byte chunks, and when I do pointer arithmetic in that, then that is a different thing. But yeah, so this is a pointer. So ARR does not take a space in my stack similar to other pointers. ARR itself, basically the name itself won't take a place into stack, and it will point to here to this actual ARR, right? It will just, it is just a symbol which is pointing to this address. But in this case, if I make a pointer, then the compiler will allocate a memory for pointer variable itself of what, 4 byte, and this will contain the address of my ARR. So this is my ARR, which is 20 byte. The first element address will be stored here if I make a pointer out of it. But yeah, ARR does not have a physical space of its own inside my memory. So this is what the difference is. Let's quickly go through the differences here. So one other thing, ARR is the data and P points to that data, correct? So if I make this kind of stuff, so why I have not used, unlike other things, why I have not used AND operator? Because there is a concept called as array decay, where the name of the array itself, similar to the function pointer that we have studied, the name of the function itself was the address. Here the name of the array itself is the address, so I don't need to do anything and operation or like that. So in after executing this, your memory will look like this. So inside stack you will have a chunk of 1 2 3 4 5, and this is will be your actual array of 20 bytes, and the addresses of each element you can see. So it will be 100, then 104, then 108, then 112, then 116, like that. So these are all in decimal numeric terms. Then after that, if you see p is just a variable, pointer variable, which stores some address. So this is 4 byte, and which is pointing to my this location, first location. So value of pointer, if you see, 100, and the value the pointer is pointing to is 1, correct? The major difference comes here when you use size of operator. So size of operators behave very differently for ARR and P. If you go for size of P, then it will be 4 byte because it's just a pointer for 32-bit machine, and if it is a 64-bit machine, sorry, then this is the thing. Okay. Third thing, incrementation. So p++, you can change the value of p++, but again x is a symbol, you cannot change it. If you do ARR++, then it will give you compile time error. Yeah. So the basically array doesn't represent anything, right? It is just a symbol. If you try to increment it, it is not a variable in a memory that will increment itself. Yeah. So yeah, this is one thing. You cannot change, again, you cannot overwrite it also. You cannot make it point to any other thing. Once it is initialized, it will always point to that point. But you can anytime change a pointer to point to any other memory location or address, right? So here it is written that ARR behaves like an implicit int const variable. So basically this int const, you don't have an idea about it right now, but think of it as like a pointer whose value cannot be changed, right? But there is one special thing about ARR is address of and behaves differently, right? So if you try to print out the address of ARR, then it is 0x111. If you try to print out and ARR, then it will print you this same thing, right? But if you try to print out and ARR plus 1, then it will jump to the whole location. It will jump 20 bytes together. So this is one very important thing that you have to if you try to print out this, then it will give normally as a pointer jump by one four jump. If we come to the pointer p, if you try to print out the value of p, it will be 0100. But if you try to print out value of and of p, you know that p is itself a variable which is stored in memory, so it will print the address of p itself, right? So address of p itself is 0x200. So it is lying in some different memory location. If you make and p plus 1, basically and address of p plus 1, then it will jump by 4 if it is a 32-bit architecture. Okay, I'm assuming it is 32-bit machine. Okay, so this thing you will get to understand more when I teach you pointer to const and const pointers concept. There is a concept called as array decay. So whenever I pass ARR to some pointer function, basically like this, then this ARR will decay to address. Now this P will behave normally like an pointer. Okay, so this is a function concept called as array decay. Don't need to go into too much detail of array decay, but yeah, since we are passing the address of this array to some pointer, so now it is a simple pointer for this inside this function. So P can be used as a simple function inside the inside that particular function. Okay, so this is what written here. When passed to a function, array loses its nature and become a pointer. This is called as decay. Size information is gone inside 4. So whenever you see a function call, you will always see size of array. You are passing the size as well, correct? Whenever you see a function call in which we are passing an array, you are passing the size of array itself. So this is very important. Okay, because it loses the information of size information is only where the array is declared inside that scope only. Okay, then comes to the arithmetic. So arithmetic will look very same. So ARR2 is exactly equals to ARR plus 2, and we are then dereferencing it. Same goes for the pointer. If you are incrementing the pointer, then dereferencing it, it is the same thing. Same thing here as well. So these all are identical. That's why people always confuse ARR as a pointer. ARR is not a pointer. It's just a symbol. It have no physical memory inside your similar to pointers. It doesn't have a physical memory, right? Then comes your heap. Only pointer can do this. So basically, this is not important for you. Quickly just pause the video and see the summary, otherwise the video will be very long. Just a summary of everything is here now. Yeah, so that's it.